Welcome to All This Math. This is Professor Parker, and tonight we're going to be doing some work with parabolas, graphing them and finding out some information about them. So here we have, well, first let's take a look at what our instructions are. Our instructions are to find the vertex, the axis of symmetry, the y-intercept, and x-intercepts, if they have any, because every parabola won't have an x-intercept, because every parabola won't necessarily touch the x-axis. So if it don't touch the x-axis, there are no x-intercepts. For example, you could have a parabola that might go like this, boom, and not even hit the x-axis. Or it could go like this, boom, and not even touch the x-axis, right? That could happen, all right? Now, I threw out the word parabola, but how do we even know this is going to be a parabola? All right, this is how we know it's going to be a parabola. If your biggest exponent is a 2, and it's set up in what's called vertex form like this, where you have like f of x, or it could be a y right here. Like, matter of fact, that's what I'm about to do. I'm about to rewrite this right now because I'm going to do that anyway, because this represents a function, but f of x and the variable y are the same thing. So just make sure you know that. F of x and y are the same thing. So let me rewrite this drawing real fast. Y equals the quantity x plus 1 squared minus 4. Right? I could just replace the f of x with the y, because all it means is y is what it is because x is what it is. X is independent, and x makes y what it is. So that's why x is inside of the parentheses next to the f, because y is based on whatever x is. So whatever number you put in for x is going to determine what y is going to be. So that's why y and f of x are the same thing. That's one way to think about it, right? But anyway, this is called vertex form, because when you look at it, you can immediately see what the vertex is going to be, right? Just like how when you look at the slope-intercept form of a linear equation, you can look at it right away and tell what the slope is and what the y-intercept is, because they're right there in front of you, right? So the vertex, this is your x value and this is your y value. But something kind of weird happens, and it's based on what the general form or the general vertex form of an equation is. Instead of the x value of the vertex being a positive 1, it's actually going to be a negative 1. So just for now, just remember that whatever value is inside the parentheses, along with the x, right? The opposite of that number is the x value of the vertex. So because this is in what's called vertex form, we don't have to do any real calculations or any real mathematics to figure out what the x value of the vertex is. If this had been in standard form, then there's another formula we use, negative b over 2a. Negative b divided by 2a would give me the x value of the vertex. And then I'd have to take that, throw it back into the equation to figure out what the y value of the vertex is. All right? But we don't got to do that with this one because this was given to us in vertex form. All right? So let's just write this down. Vertex is, and remember what I said, whatever number is inside the parentheses, that's going to be your x value, but you got to take the opposite of that number. So I got positive 1 right here. So that means that the x value is actually negative 1. And this is the y value. This negative 4 right here. All right. So I know my vertex. That's my first piece of information. All right, now, the axis of symmetry. Now, what does that even mean? That means when we draw the parabola, which is going to look like this, right? Because, and how do I know it's going to open up like that? Because imagine there's an invisible number in front of these parentheses, right? An invisible positive 1. There's no negative sign right there. So that means there's an invisible positive 1 right there. So anytime there's a positive number in front of the parentheses, that means that the parabola is going to open up. If there was a negative sign or a negative number in front of this, like a negative 8, negative 2, negative 1/3, then this will open down, right? Negative goes with down, positive goes with up. So there's an invisible 1 right here and an invisible 1 right here. So that's a positive 1. So that means your parabola is going to open up. All right. So the axis of symmetry is the axis or a line that basically cuts the parabola in half, right? It's a vertical line that's going to cut that parabola in half, right? And make it symmetrical. Symmetrical meaning balanced, meaning that there's going to be just as much of the graph on the left side as there is on the right side. That's symmetrical. All right. So I'm going to call that the AOS. And the AOS is a line. So we say x equals, it's gonna go through the vertex. So if it's a vertical line and it goes through the vertex, it's got to go through -1. So it's a vertex. So it's a vertical line, I mean, that goes through -1. So the graph is just x equals -1. And you should remember that whenever you graph a vertical line, the equation is going to be x equals some number. And it's going to be equal to the x value of any point on that graph. All right. Now, in this particular case, because we're dealing with a parabola, the axis of symmetry is going to cut the graph in half. And the vertex is kind of like the halfway point, right? Where the graph is going to be divided up. And you'll see it'll make more sense once I actually draw the graph. All right, so we got our axis of symmetry. Now, what about the y-intercepts? All right, y-intercept. By definition, the y-intercept is the value of y when x is 0. Again, the y-intercept is the value of y when x is 0. So I can go to my equation, and that's another reason why I switched out the f of x and put a y there, because I knew we was about to do this. All right, so I'm going to plug in 0 for x, because by definition, the y-intercept is the value of y when x is 0. So I'm going to do y equals 0 plus 1 squared minus 4. And then I just use my skills with basic computation on the right side of the equation. A little bit of order of operations, you know, something light, right? Inside the parentheses, I do 0 plus 1, I get 1. And then I do 1 squared. 1 squared is 1 times 1. That's 1. And then I do 1 minus 4, and I get -3. So my y value is -3. And that's my y-intercept. All right? So that's my y-intercept. So let me do this. Y-int. Y-intercept, right? So that's going to be a point 0, -3. All right, so now I got the y-intercept. Last thing I need is my x-intercepts. This is the part that's going to take a little bit of work. The reason I know that, because I did this problem already. That's how I know that. It's going to take a little bit of work. All right, so now dig this. By definition, the x-intercepts are the values of x when y is 0. Just like the y-intercept is the value of y when x is 0, the x-intercepts are the value of x when y is 0. All right, so now let's do this. Let's say x-intercept. Make sure you can see me in the camera still. All right, x-intercept, right? I'm going to go use this equation right here, and I'm going to replace the y with a 0, and then I'm going to do x plus 1 squared minus 4, okay? Now, we got to expand this. I got to basically take this out of vertex form, right, and put it in a form where I could either use the quadratic formula, I could complete the square, or I could factor. If I'm lucky, I'll be able to factor, right? Because factoring is probably the most efficient and easiest way to solve for x and get the x-intercepts. So first I got to expand this, right? So I do 0 equals x plus 1 times x plus 1 minus 4, right? Because x plus 1 squared is the same thing as x plus 1 times x plus 1. So I'm going to do a little bit of FOIL method, which you're probably familiar with already. The FOIL method. FOIL like aluminum foil. First times first, x squared. Outer times outer is x. Inner times inner. And FOIL is just an acronym that stands for first, outer, inner, last. That's all it is. All it is just a reminder as to what I have to multiply together when I'm multiplying two binomials. It only works with two binomials. It don't work with trinomials. It don't work with a trinomial and a binomial. It only works with two binomials. Like these right here. Binomial, binomial. So anyway, back to what I was doing. So I got x times x, which is x squared. And then I got x times 1, which is x. And then I got the inners, that's what the I stands for. 1 times x, which is x again. And then the L stands for last. Last in the parentheses is 1. Last in these parentheses is 1. The x's were first. So that's plus 1 minus 4. And then I just clean this up, you know what I mean? Like just combine like terms, whatever terms I can. So the x squared is by itself. It's nothing to match up with. The x squared can't match up with anything. So the x squared is by itself. But these two x's, they can go together. They become 2x. The 1 and the -4, minus 3. All right? So now, that's now what we call in standard form, x squared plus 2x minus 3. So now, what I want to do is I want to solve for x. Now, one of the ways I can solve for x is by factoring, I hope. And I'm about to find out right now. So this is a quadratic trinomial, right? So because it's a quadratic trinomial, I'm going to try to do something that we call the reverse FOIL method, all right? Where I take the square root of the first term, or the quadratic term, and I place that, and I create two binomials. And I place the x here and the x here. And then what I'm doing, because now factoring is kind of tricky. Now, it's a lot of different ways to factor quadratics. It's a lot of different ways to factor different types of expressions in algebra. But one of the ways, when you see a trinomial that is a quadratic, right, and the lead coefficient is a positive 1, then you can do something that I like to call reverse FOIL. Whereas I just take the square root of the first term, which is x, and I place an x here and an x here, and then I'm looking for two magic numbers. Two magic numbers. Now, what you mean? Now, you might be wondering, what do you mean by magic numbers? Well, I'm looking for two magic numbers that multiply together to make negative 3 and add together to make positive 2. So again, they multiply together to make the last number, and at the same time, those same two numbers add together to equal 2. And I know that those numbers are going to be positive 3 and negative 1. How do I know that? Because positive 3 times negative 1 equals negative 3, and positive 3 plus negative 1, which is the same thing as positive 3 minus 1, equals positive 2. So why did I do this? I did that because now I created two linear expressions that can be set up as linear equations that I can solve for easily with one step. Watch this. X plus 3 equals 0, right? And then I got x minus 1 equals 0. So yeah, I had to do all of this just to get to this point and then solve for x. So now I'm going to subtract 3 on both sides. I got x equals negative 3. I subtract over here. Oh, I don't subtract. Chill. Don't subtract. You got to do the opposite. You got to add 1. I add 1 on both sides over here. So that gives me x equals 1. So these are my two x-intercepts. Negative 3 and positive 1. Right? Let me switch my mark up before I get into this graph. Right? Because I don't want my marker to be all dull. Right? So now, I got everything I need. I got my x-intercepts. So apparently this parabola does have x-intercepts. It is going to cross the x-axis. All right. Now, I'm going to just first I'm going to plot my vertex, right? I'm going to plot my vertex. Now, when you think of what a vertex is, I probably should have said this earlier, but a vertex is, if the parabola goes like this, it's the point where the parabola stops going down and starts going up again. Now, if the parabola was going like this, right? It's the point where the parabola stops going up and starts going down, right? Like a roller coaster, like the high point on a roller coaster or the low point on a roller coaster. That's the vertex of a parabola. All right, so what's negative 1, negative 4. What are my coordinates? So that means I start at the origin, I go to negative 1, and then I go down 4. 1, 2, 3, 4. That's my vertex right there. All right, now my axis of symmetry, I also want to draw that. My axis of symmetry just goes straight through the vertex. I'm going to just do like vertical line straight through, just like this. All right. It's not perfect, but it's good enough. All right. That's my axis of symmetry. Now, my y-intercept. Where's my y-intercept at? Negative 3. So I go to negative 1, negative 2, negative 3. Right there. All right. And then where are my x-intercepts? Negative 3 and positive 1. So I go on the x-axis, not the y-axis, the x-axis. I go negative 1, negative 2, negative 3. Boom. That's one of them. And then over here from the origin to positive 1, boom. That's the other one. All right. Now, some teachers want you to set up a table of values and find more values for x, which will then in turn give you more values for y. If your teacher would like you to do that, that's fine. But right now, for these purposes, I'm just going to do kind of like a quick and dirty sketch based on my vertex, my y-intercept, and my two x-intercepts. All right. So again, I told you the vertex is the lowest point. And of course, the parabola must go through the y-intercept So it's going to go like that. Now, you don't want to make it shaped like a V, because a V represents the absolute value function. And this is not an absolute value function. This is a quadratic or a parabola. So it should look kind of like a U, kind of U-ish. You know what I mean? So then I'm going to go this, I'm going to do this, and I'm going to do that, like such. All right? And that's the graph of this parabola right there. So again, what we did, we found the vertex, we found the y-intercept, and we found the two x-intercepts, right? So you see how the graph, it crosses the x-axis at the x-intercept. It also crosses the x-axis at the x-intercept over here. And this is the work we had to do. Basically, when you're finding the x-intercept, you're solving for x. That's what you're doing. You're solving for x. When you're finding the y-intercept, like I told you, you make x 0, and then you solve for y, right? That's the definition of a y-intercept. The y-intercept is the value of y when x is 0. I mean, peep the graph, right? Like at this point right here, this is the y-intercept. This point right here, what's the value of x? X is 0. This point, if you write the coordinates of it, it is 0, -3. That's the y, that's the x, see? I told you. Y-intercept. Value of y when x is 0. Oh, let me do it for the x-intercept too. The x-intercept is the value of x when y is 0. And then over here, the value of x when y is 0. All right? And that, of course, is the vertex, which is -1, -4. All right, so I hope you learned something. And please like the video. Please share the video. Please subscribe to the page. Please tell people about the page. And as usual, do remember that there's all this math all around you.